Myself, Dr. K. Viswanath, Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study a problem on how to solve for a beam of overhanging with a combination of loads, both uniformly distribution load and point load. We can see here in this problem, there are two supports are there. One is knife edge support and another one is hinged support. And the another one is roller support. This is the roller support and it is the knife edge support. There is the UDL. The span of the UDL is 4 meters and total span of the beam is 10 meters. And there is a point load which is acting at the extreme left hand of the beam, that is 25 kilonewtons, acting at a point at a support from roller support at a span of 4 meters. So how to solve shear force and bending moment diagrams in this case? So let us begin. Whenever there are two supports are there, we have to find out their reactions. Here it is knife edge support. There will be one reaction, and here it is at point B. There is a roller support and one reaction, RB and RA. How to solve this problem? Whenever we are going to solve it, we have to find out support reactions at RA, at point A and point B with the help of equilibrium equations such as algebraic sum of all vertical forces equal to 0 and algebraic sum of moment equilibrium about any arbitrary point equal to 0. By using these two equations, we are going to find out the two unknowns, which are AY at reaction at point A and reaction at point B. Now, the AY plus BY upward forces equal to downward forces. That is AY plus BY equal to total load, that is 5 into 4, 20 plus 25, 45 kilonewtons. AY plus BY equal to 5 into 4, that is 20 plus downward forces 25, total 45 kilonewtons. Now take a moments about any arbitrary point here, that is support A. We are going to take a moments over A. Now the reactions are, here in this case, algebraic sum of moments equal to 0. It is nothing but clockwise moments equal to anti-clockwise moments. Here it is sigma m FV equal to 0. That is algebraic sum of all vertical forces equal to 0. That means upward forces equal to downward forces. Now upward forces are AY plus BY. Downward forces sum is 45 kilonewtons. Now the moments are anti-clockwise moments. That is BY into perpendicular distance, that is 6 meters. That is anti-clockwise. These are all our clockwise moments. So the clockwise moments are 25 into 10. That is 25 kilonewtons into clockwise direction. 4 plus 4 plus 2 meters. That is 10 meters. That is 25 into 10 meters. Plus this UDL is converted into uniformly distributed load, is converted into concentrated load. That is 5 into 4, 20 kilonewtons, which is acting off of the UDL from this here, that is 2 meters, 2 plus 2, 4 meters. 5 into 4 into 4. Then 250 plus 80 by BY equal to 250 plus 80 by 6. That is 55 kilonewtons. Now BY equal to 55 kilonewtons. Now substitute over here, that is AY plus BY 55 equal to 45. Then AY equal to minus 10 kilonewtons. That means what we assumed, the assumed force is reaction is acting upwards. But based on this value, we understood that the direction of the force acting on support A is downwards. That is 10 kilonewtons. After calculating support reactions, now we are going to find out shear force values for drawing shear force diagram. What is the shear force values? The shear force value at AY is downwards, that is 10 kilonewtons here. Now we know the sign conventions. The sign conventions with the section upward is positive and rightward is also positive. This is the positive shear force sign convention. The negative shear force sign convention is leftwards downward direction and right side of the section is upwards. This is the negative shear sign convention. We can see here this is the sign convention of positive shear force and negative shear force. So shear force at point A, that is 0 kilonewtons, A left and A right, it is acting downwards. So at acting downwards, right side of the section, it is downwards, that is the negative shear force, that is minus 10 kilonewtons. Up to C, this minus 10 kilonewtons is acting constantly. At C onwards, at C right, then next to point B, if you go to B, there are the two loads are acting. One is our concentrated load plus UDL. Both are acting downwards. That means here you can see it. Here it is acting downwards. Then minus 10 minus 35, that is minus 45 kilonewtons. Now minus 10 minus 5, minus 10 minus 5 into 4, minus 10 minus 5 into 5 into 4 20, minus 20. Then it what happens? That is minus 30 kilonewtons. Okay, minus 30 kilonewtons. Now here FD right, if you go to FD right, this is the left side and FD right, what will happen? Minus 30 minus 25, that is minus 55 kilonewtons. And if you go to beyond that, it becomes 0. So now here, the shear force section at BY, if you go for it, FD right, then what is the FD right is, if you consider it FD right, shear force at FB right, if you consider, now minus 10 minus 20 plus BY is acting downwards. What is the BY force? The BY we considered here, it is, that is 55 kilonewtons plus 55, that is shear force at B right, FB right, that equal to minus 30 plus 55, that is plus 25 kilonewtons. If you go beyond this, plus 25 kilonewtons are acting up to point D. Then after D, plus 25 minus 20, it becomes 0. Now how to draw? By using these values, shear force diagram. Yes, at point C, there is a point load, it is minus 10, coming downwards and constantly up to C. Up from C to B is the UDL, uniformly distribution load. That means it is varying linearly. Now it is up to minus 30, coming downwards up to minus 30. At 30, it is suddenly changing to positive value. From negative to positive, that is plus 25. That is plus 25. From point B to point D, it is constantly acting. That's why it is 25 as a constant. Why it is become constant? Because concentrated load from B to D is concentrated load is affecting. C to B is uniformly distribution load is acting. Now let us calculate bending moment values for drawing bending moment diagram by using bending moment sign conventions. Here we know the bending moment sign conventions. The bending moment sign conventions, this is the positive. This is a positive moment, both are upwards, and it is negative moment, the both are downwards. Now here's the positive bending moment. Let us calculate here how it is acting. AY at AY is 0. MA moment at A is equal to 0 kilonewton meter. Up to at point C, this AY is acting downwards. That means negative. AY into 2 meters. What is A into 2 meters? At AY it is minus 10 into 2. That is minus 20 kilonewton meter. At B, there are all are acting downwards negative. Minus 10 into minus 10 at movement at B equal to minus 10 into how many? 6 meters minus 5 into 4 into 2. This is the value, that is minus 60 minus 22 minus 60 minus 40, that is 100 minus 100 kilonewton meter. It is acting negatively, but there is a UDL, so it follows second order curve, that is parabolic law. Now up to point B. At point B, what is happening? At point B, it is minus 10. At point D, how to calculate at point D? Let us calculate at point D. That comes as 0 kilonewton meter. So shear force at point D, bending moment at point D, MD equal to minus AY. This is AY into 10 meters minus 5 into 4 into 2 plus this distance, 2 plus 4, 6 meters equal to 0. Then it comes as a 0 kilonewton meter. Now by using these values, how to draw the shear force diagram? At point A, suppose A is equal to 0. At point D, it is 0. Whereas at suppose B, it is minus 10 kilonewton meter. From C to B, it is a parabolic curve. It is the parabolic second order curve. is the second order curve. From point A to C is the linearly downwards is the straight line, that is minus 10 to minus 20, minus 0 to minus 20, minus 20 to minus 10, minus 100, minus 100 to 0. Why it is the straight line? Because B to D, there is a movement is the straight line. It is varying linearly. This is a single order curve. Whereas C to B, it is a second order curve. It is following parabolic law. So from this we can understand from comparing what is the interpretation between from shear force diagram and bending moment diagram. Where shear force is changing the sign, the point 0 is the maximum bending moment is observed, that is minus 100 kilonewton meter. Thus we will calculate shear force and bending moment calculations for drawing shear force and bending moment diagram for a case study of overhanging beam, which is subjected to uniform distribution load and point load. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.